matrix R. Matrix Q is an orthogonal matrix. Think of it as a matrix where all the columns are at perfect right angles to each other, like perfectly aligned axes. Each column is also normalized, meaning its length is 1. The matrix R is an upper triangular matrix. It looks like a triangle because all the elements below the diagonals are 0. Why QR decomposition is important? Now you might wonder, why should we care about QR decomposition? Well, it's incredibly useful, like for solving linear systems. Let's say you have an equation like Ax is equals to B. QR decomposition lets us rewrite A as Q into R, and solving this is much easier. This is super common in machine learning. And the next application is eigenvalue computations. QR decomposition is used in the QR algorithm to calculate eigenvalues, which are key in areas like principal component analysis. And finally, it is used in numerical stability. It ensures reliable results in machine learning and scientific computations. How does QR decomposition work? Let me walk you through the steps of QR decomposition algorithms. First, we start with the matrix A. This is a matrix you want to break down. Then we initialize the matrices Q and R. Q will hold the orthonormal vectors and R will hold the upper triangular values. And then we will compute the vectors U using the projection formula to create the intermediate vectors U. Here's the key part. We calculate intermediate vectors U by removing the overlap of the current column of A with the previous column of Q. And then we normalize the U. Once we remove the overlap, we normalize U to get unit vectors, which we store as columns of Q. And then we construct R. R is calculated by projecting A onto Q by the formula R is equals to Q transpose A. And finally, we verify the decomposition by multiplying Q and R to check that A is equals to Q into R. This ensures that decomposition is correct. Now let's walk through the Python code implementation. First, we import NumPy. This library is great for handling matrices and performs mathematical operations in Python. Here, we will define a function called QR decomposition, which takes a matrix A as input. This is the matrix we want to decompose. We extract the number of rows M and number of columns N from A. This tells us the size of the matrix. Next, we initialize Q as a zero matrix with the same dimensions as A. This matrix will eventually hold the orthonormal vectors. Similarly, we initialize the R as 0, R matrix as a zero matrix, but it's a square n by n matrix. This will hold the upper triangular matrix. Now we loop through each of the column of A. The variable j represents the current column we are working on. We extract the jth column of A and call it as V. This is the column we are going to orthogonalize. Then we loop through the previous columns of Q using I. This is to make V orthogonal to those columns. Here we calculate the projections of V onto ith column of Q. The result is stored in R I by j, which represents the magnitude of the projection. Next, we subtract this projection from V. This removes any component of V that overlaps with the previous column of Q, making V orthogonal. Once V is orthogonal, we calculate its length or magnitude using the np.linearalgebra.normalize of V. This value is stored as R j by j. Finally, we normalize V by dividing its length. This creates a unit vector, which becomes the jth column of Q. At the end of the loop, the function returns the matrices Q and R. To test the function, we take the matrix A as an input from the user. The input should be in nested list format. We call the QR decomposition with our input matrix A and it returns Q and R. Finally, we are printing Q matrix, which is the orthogonal matrix, and R matrix, which is the upper triangular matrix. Now let's visualize the output. The user gives the input as a nested list A, which is the stored as a matrix A in the above code A. And it is passed to the QR decomposition function, and the function does the Q and R initializations, and it changes the values as Q is an orthogonal matrix and R is an upper triangular matrix, and finally we get the matrices like this. The first nested list is the Q matrix and the second nested list is the R matrix. And if the user enters like this, we will get the output like this: Q matrix and R matrix. To wrap up, QR decomposition breaks down a matrix A into Q and R. It is widely used to solve linear equations, calculate eigenvalues, and improve numerical stability. We also saw how the algorithm works and how to code it in Python. Thank you for watching, and I hope this explanation was clear and helpful.